I'm building an LS-swapped all-wheel drive extended cab Chevy S10 to create what I'm going to call a second-gen Cyclone. My ultimate goal is to make more power, have a lighter weight, and go faster than the COPO truck I built a couple years back. But there is one fatal flaw with the S10 chassis that needs to be corrected before we do any power upgrades, because if I don't, there's a very high likelihood the entire drivetrain could self-destruct. When Chevy designed the S10 pickup truck, they never really intended for it to be used as a hot rod. So most of the parts in the drivetrain just aren't adequate. They're not strong enough. The trucks were designed with a V6 or a 4-cylinder. This is the V6 version. But before I add the V8 and then supercharge it or turbocharge it down the road, I wanted to get rid of all the weak links in the system. So I kind of got ahead of the curve last fall. I started by replacing the factory 7.5-inch rear axle with a stronger 8.5-inch version from a ZR2. We did the same thing up front. We replaced the aluminum front differential with a cast iron version, which again is much stronger, much more rigid. And then finally, the last part of the drivetrain that I'm going to upgrade is the transfer case. We have an NV149 under the shelf there. Full-time all-wheel drive transfer case that, for what I'm going to be doing, is practically bulletproof. But there's one thing that I need to address, especially after seeing the footage that I'm about to show you, because if I don't, something is absolutely going to break, and that is the rear suspension, the leaf springs, and specifically the wheel hop that comes along with it. So I've experienced that in the real world a handful of times. Once just trying to do a burnout, another time just in the rain, taking off, getting a little bit too heavy on the throttle maybe. Same thing happens though. The truck just skips up and down, it shakes, it's violent, and especially after seeing it in slow motion, it is downright scary. So we need to address it. Now, there's nothing inherently wrong with a leaf spring design. I don't know if it's just these particular springs or not, but you actually can make them work with big horsepower. Like on my 1700 horsepower four-wheel drive drag truck, I'm using leaf springs. On my 800 horsepower turbo big block street truck, I'm also using leaf springs, but those both have something that the S10 does not, and that is a set of cowl tracks. Now, I could just take what I'm going to call the easy route and install some cowl tracks on the S10, and it would solve all my problems. They connect below the axle, they pivot up on the front of the leaf spring bolt, they plant the front of the spring, they help increase traction, and they stop wheel hop, which is the first symptom that I'm trying to fix. But there's a few reasons why I don't want to do that. Number one is ground clearance. The cowl tracks do stick down below the leaf spring just a little bit, and the truck is already sort of low to the ground. I know that's definitely not a deal killer for everybody. Number two, cowl tracks are designed primarily for straight line acceleration. So it may work on an autocross or it may work on a road course. But the third reason is simply that I just want to build my own 3-link. It's kind of been a bucket list item for a while. So that's exactly what we're going to do, because it's maybe a more elegant or complicated way of solving the problem. It gives me more adjustability, more tunability, and I think for the overall goal of the truck, it's what I need to do. So we have ourselves a whole pile of fabrication parts. We'll go over these in detail a little bit later on, but if it all goes well, by the end of this video, we will have ourselves a 3-linked rear suspension that won't do this. That is damage from our axle hop. Basically, the pinion gets so high it jams the bolts into the aluminum yoke. Yeah, that's not good. On a solid rear axle equipped vehicle like our S10, the rear suspension system is responsible for a couple of different things. Number one, its job is just to hold up the weight of the vehicle. That's what the spring does. But number two, it also has to locate the axle underneath the truck, both front to back, side to side, and prevent it from twisting under acceleration, which is exactly where our factory leaf springs are failing us at the moment. So by designing a multi-link rear suspension, basically we're going to be isolating all of those jobs into separate components. There's going to be 3 links that run front to back along the vehicle that's going to hold the axle front to back and prevent that twist from happening. There's going to be a 4th link that runs side to side called a panhard bar that's going to keep the axle centered under the vehicle. And then finally, the weight is going to be held up by a pair of adjustable coilover shocks. With an original leaf spring setup, there's really no adjustment in terms of how the chassis reacts or interacts with the spring. The spring is just there. But by converting to a multi-linked rear suspension, whether that's a 3-link, a 4-link, a 2-link even, or radius arms or ladder bars, you can basically dial in how the vehicle reacts under different conditions like acceleration or braking. The great thing about the 3-link that we're going to be designing is it'll have some adjustment built in. So we can dial in something that's called anti-squat, where as the power is applied to the rear end, we can actually lift or separate the chassis from the suspension, which can kind of plant the rear tire into the ground to improve traction. Or we can have some weight transfer where under acceleration, the rear axle kind of lifts the front of the vehicle, which also transfers some weight to the back and kind of helps plant the tire again into the pavement, because the whole objective here is to increase traction and also prevent that dreaded wheel hop that we just saw. Now this is going to be a 100% custom designed and built rear suspension system. I did kind of look at some off-the-shelf options. I believe RideTech has one, which was probably my #1 contender, but that was designed for a 2-wheel drive S10, and there are a few differences in the chassis. There are a couple more universal 4-link options, but just given the constraints of the chassis, I didn't really feel like those would be a perfect option for what I was trying to accomplish. So the parts that I'm about to show you, they're all designed around an off-road style suspension. They're huge, like the heim joints are 7/8 of an inch, so it's way overkill and way strong, but it's gonna do exactly what I want in exactly the way I want. Short while later, we've got all the old leaf spring brackets cut off the frame, the welds have been ground down and smoothed out, and we basically have ourselves a blank canvas upon which we can build our own custom 3-link suspension. Same thing on the axle, old leaf spring brackets ground off and smoothed out. Now, when we get to welding, it might look like we're just throwing these brackets on in any old spot and hoping it kind of works out, but that's honestly not what's happening here. I have spent countless hours researching and engineering, if I can call it that, and designing what I think is going to be the ideal suspension geometry, but then packaging it around an existing frame and an existing set of constraints like the fuel tank, an inboard mount and exhaust system, you know, the wheels and tires on the outside, for example. There's not a lot of space. A 4-link is probably more popular, but given all those things I have to work around, a 3-link is really, I think, the best situation, and it'll give me a lot of adjustment. As far as geometry goes, I won't get into the specifics of what does what, but here's kind of my final calculations of what we're going for. I was targeting 75% anti-squat. As you can see right now, 74.76%, and this is just kind of a rough visualization, the lower links, the upper links. This is the top view, you get the center link, that's the panhard bar. And then we have an instant center length of 74 inches. Now, based on my research, I feel like that's going to give me a pretty good all-around performing suspension. It'll work okay at the drag strip, at the autocross, at the road course. And with an anti-squat of 74, basically when we accelerate hard, the rear end's going to go down just a little bit and the front end will come up. It's going to transfer some weight. For a pro touring triple threat type of build, everything I read said that's a pretty good baseline to shoot for. But if in the real world that doesn't work out, we do have some adjustment built in, so we can dial that in almost wherever we want it, whether that's anything from like 60 to 130% anti-squat is what we'll be able to do. This is the kit that we're using, or kits I should say. This is all basically off-road stuff, so it's like super overkill. This is a So the kit here, the 3-link, is from Ruff Stuff Specialties. It comes with, of course, all the DOM we need for the links themselves. It's got like the brackets, how to get these kind of welded together with the TIG. It came with these lower axle mounts, which I'm not going to run these just because, again, adjustment. But I did pick up this from Barnes 4-wheel drive. These are going to be my new lower links on the axle, or the lower brackets. And when I notch that and it's going to fit right, that's the adjustment that we're going to have, about 4 inches, which again will kind of help me dial in that anti-squat so the chassis can adapt to different conditions. Let's say I'm going to a drag strip and it doesn't work out exactly how I want. We just got to move a couple of bars around. Coilovers, these are a Viking Warrior 7.5-inch travel. It's a 14-inch coil spring, 200-pound rate. We've got the brackets from QA1. This is like a 7/8 inch heim. I talked about that. That's the upper axle link mount right there. So there's a lot of brackets there, and to get everything to fit how I wanted, I just had to do a little bit of shopping around. If I had to do this again, I really would probably consider investing in like a CNC plasma, because there's, you know, working with an existing bracket is fine, but I could design my own and have it fit this chassis better, which in fact I had to do that. This is going to be the panhard bar bracket for the axle. Just given what I have to work around with the coilover and the link mounts and stuff, none of the existing axle side panhard bar mounts would work. So I came up with this guy. There's going to be 2 layers to it, a top and a bottom. It's going to go right on there. We'll have a little hole cut in the middle to lighten it up, and then that is going to be the axle side of the panhard bar. And then the frame side, one of the existing brackets will work just fine. So anyway, that's kind of what we've cooked up. I hope it works, but the only way to find out is to actually get it installed. So let's do that right now. All right, I'm gonna mark there, tack one side, tack the other, make sure they're square and parallel with each other. Then we kind of weld it up. So this is going to be the lower axle bracket. As you can see, it's flat. It needs to be curved, something like that. So I'm just going to take this bracket and use it as a guide for the plasma cutter. I'll kind of clamp it on here and just zip that guy out and hopefully have a nice shape. Wrong mode. Right on the money. Man, I am good. So we now have the lower link mounting brackets 100% complete, both on the frame side of the truck and on the axle. So from now, all we really got to do is put a little bit of edge primer on here, put some paint on there so it doesn't rust or anything like that. And then at least on this side, we could throw the fuel tank back in and get the truck a little bit closer to rolling down the road. With the lower links done, that's like 2/3 of what it takes to locate this axle front to back. And the other third, of course, is the upper link, which means we need to have a mounting bracket on the axle. Because I know the mounting bracket on the frame is just going to be on this cross member right in here. And that's going to exactly match the geometry that we have planned out. The upper link is a little bit shorter. The only problem or challenge we have is just packaging this. The kit from Ruff Stuff Specialties comes with this guy right here, fabricated link tower, I guess you call it. It's designed to sit on an axle tube, something like that. If I can balance this, it's kind of tricky. It's designed to sit sort of like that, which would be great. The only problem with putting it right there, though, is planning for future real estate. If you guys know me, you know I love full exhausts on all of my builds. I love it to go all the way out to the bumper at least, or at least behind the axle. I don't really love axle dumps. Yes, I know I had one on here, but it was just temporary. So I need to leave space with my suspension design to run exhaust out the back. So if I put the link tree, or the link tower, I guess you call it, right there, that's where my exhaust needs to go. I'm trying to leave at least 7 inches between the frame, which is right here, that orange mark, and the edge of the bracket, which means bare minimum, the left edge of the bracket should be here, and it'll kind of go over in this area. Initially, my plan was just to have a single mount, kind of like that, right in the middle of the top of the diff, which would be fine, except as you follow that bracket forward, there's another bracket that's going to have to sit right here on this cross member. It sticks down a little bit, so we have our adjustment, but that bracket would crash into the drive shaft as the suspension cycles. So I really need to go, if this level you could imagine is the upper link, I want to have it just inside the drive shaft so it could cycle and not hit, not that it ever's going to go that low, but also leave room for the exhaust. So somewhere between that orange line and that orange line is where our upper link bracket needs to go. That does mean I am going to have to contour this link tower to fit, and I'm kind of planning on doing it like this. That will mean I'm going to have to weld to the center of this differential, which actually isn't that big of a deal because it's made from a cast steel, not a cast iron. So welding it, even with just the MIG, won't be a challenge, really. In fact, I've already welded to it when I welded the axle tubes into the center section, which is probably now, in hindsight, a good thing because all the axle hop that this thing had may have cracked it being stock or unwelded. So anyway, unfortunately, that brings my time today to an end. I wish I could have got at least the axle mounted with all 3 links, but time just flies by when you're having fun, trying to do a couple different things at the same time here. But progress takes time, and it takes patience to do it right. I don't know, everyone argues about what's the right way to do it. I'm doing this the way I feel is right, and that does take a little bit of time. But I'm happy to do it, and I'm really excited for this project. So thank you guys. Come back soon. Next time we'll be working on on continuing this 3-link project. We'll get the upper link mounted, we'll get the actual links built, we'll get it under the truck. Our shock brackets are sort of pre-built, so that'll go on fine, and then it's just getting the panhard bar done and like a million other things. But as soon as the suspension is done, I'm gonna drive it for like a couple of days, and then the fun starts, the LS swap.